All right, guys, today we're learning about proof of stake. So it's very different from proof of work. Some of the core concepts are same, the fundamentals are same, but the way it all happens is very, very different. And what happens is basically to become a node, right? You don't have just regular nodes, you have validator nodes. And to become a validator node, the criteria is that you have to buy quite a few coins, okay? And if you buy the coins of that particular chain, like let's say Ethereum or whatever, whichever chain you're trying to become a node at, you'll have to buy those coins and then you'll get to become a validator node. And once you get to become a validator node, you'll be one of the few people who will have the authority to add new blocks to the blockchain. So let's actually learn about all of this in more detail. So a few nodes with a lot of stake get to add blocks to the blockchain, right? Not all of the nodes, but only a few nodes with a lot of stake. Stake basically meaning the amount of coins you're holding for that blockchain. All of the nodes don't have to work. I mean, they don't have to solve any cryptographic problems. They don't have to do any work. They don't have to have a lot of computation capability, right? So comparatively, very less energy is used up. And they're highly eco-friendly because less energy is used up, in the sense not all of the nodes don't have to compete, they don't have to solve those cryptographic problems, they don't have to set up huge crypto farms, right? I think there's a small typo here, I'll fix that. Yeah, so very less energy is used up, so it's eco-friendly, and this is why Ethereum recently shifted from proof of work to proof of stake, and that's being called as the Ethereum merge. The security benefits that you get are that it's difficult to take down the entire network because there are very common attacks called as the 51% attacks, where somebody takes over 51% of the entire network of the blockchain, all of the nodes, and you can do that very easily in proof of work, because if you have more computation power than 51% of the entire network, you can easily take over the entire network. But with proof of stake, you'll have to take over the 51% of the entire network, not just have computation power, right? So that's very expensive to do. So it's very difficult to take over 51% of the entire blockchain with proof of stake. So it's highly secure. And if you take over, let's say, the 51% of the entire blockchain network, then you'll be able to add any blocks that you want. So the blocks can have information like Akhil has 10,000 Ethereum or something like that, right? You can add any random information in the blocks, and so that you're not able to take down the entire network with you. Proof of stake is a lot more secure, and many nodes with high stake are competing to add the block, and the node. So the condition is that if there are many nodes, all of whom having high stake, they're all competing to add the block, then the node will be selected at random. But also there's also an element of weightage. The weightage is always given to the node with maximum stake. So the more stake you have, since it's proof of stake, the higher your chances of being able to add a new block to the next to the blockchain. Now the validator, they keep changing for every single transaction. I mean, it's not that only one validator will always keep winning for every single addition of the block to the blockchain. So just to that's something important to keep in mind. Also, there's no reward as such, right? Only the transaction fee. So whenever you use Ethereum, whenever you send Ethereum to somebody, or you get Ethereum from somebody, or you buy NFTs, all of that, all of these transactions have transaction fees, the gas fees that you pay. Whenever you use Ethereum or any of these currencies, right, you pay a lot of gas fees, and this gas fees is basically the transaction fees that the validators will earn. So the validator nodes will get to earn through the transaction fees, basically. So it's highly sustainable, and it's great for long term because it takes up less energy, takes up less resources. There's no cryptographic problems to be solved here. Processing power required is less, and you end up basically incentivizing the people to buy more coins, because the more coins you buy, the more stake you have, and the more your chances of getting to add the next block. And that means that the currency itself starts to have a lot of value, and this is why Ethereum, people like to buy Ethereum, because it has a lot more value, intrinsic value, because the validators have to keep buying a lot of Ethereum. Okay, so 4 more important points that I want to take you through is Ethereum requires 32 ETH to be staked before you can become a validator node. So all of this that I'm talking about is not sci-fi. If you want to become a validator on your own, you can go ahead and do that. You can become a validator with ETH, but you need to have 32 ETH with yourself before you do that. And stake comes from the code of Hammurabi, which says eye for an eye. Or if you've read the book Skin in the Game by I'm forgetting the name of the author. It's the same author who's written The Black Swan. Yeah, Nicholas Nassim Taleb. If you read read the book Skin in the Game, you'll understand that basically the people who have a skin in the game are less likely to put the wrong blocks. So because you're staking or you're buying 32 ETH to become a validator, and then you have to keep buying more and more ETH, you will not want to add a wrong block which is basically with malicious content or content that is random, which is not the correct content. You wouldn't want to update the blockchain with the wrong block, because your entire 32 ETH, which is a lot of money, will completely get wiped out. It'll get completely wiped out because the other validators will find out that you added the wrong block, and that's a big problem. So your question could be, how will the other validators find out if there's a wrong block? That's because all the validators have an entire copy of the entire blockchain. As you've seen in the blockchain visualizer demo that I'd shown you a couple of videos back, where we saw how the blockchains work and how the copies of the entire blockchains exist with each of the nodes. So they'll know, they'll compare the blockchain, they'll know that there's a problem, and then it will basically lead to your money getting disappeared. Okay, so you wouldn't want that. Now Ethereum requires 128 validators, and 2/3 of the entire network of these must agree for the new block to be added to the blockchain. Some problem with my whimsical today. Anyhow, so I hope many of the things are clear with proof of stake. One more diagram I want to show you is that proof of stake versus proof of work. So proof of work, you have to have a lot of mining capability, in the sense a lot of computational power, and that is directly proportional to your mining capacity. Here, you just have to buy a lot of the coin. So that's why the value of the coin keeps increasing, or at least is much more stable. In theory, at least. In reality, the markets are subjected to people's perceptions, so a lot of things happen there. But in theory, seems to be more stable. Miners have to solve a cryptography problem in proof of work. Here, they don't get a block reward. Instead, they get transaction fees. They collect transaction fees, which the users have to keep paying whenever they use the currency. In case you've built anything using Solidity, or if you've built anything on the Ethereum blockchain, you know that you have to pay gas fees for any single operation to run, any computational operation that you run by creating a smart contract. If none of these words are making sense to you, it's completely okay. We'll talk about them in the future. But in case you've built a smart contract before on Ethereum, in case you've deployed it, you'll know that there are some payable functions. For any of those functions to run, they'll cost you gas fees, and basically these are the gas fees that these validators will get to earn. Here, like I mentioned, the security problem that hackers can have a computer. It won't be a single computer. It'll actually be a big chain of a lot of computers, a complete mining farm, and they can have a powerful network, and then they'll get to hold the 51% of the entire network, and they can add a malicious block. But here, the hacker would have to own 51% of all the cryptocurrency on the network, which is very expensive. It's practically impossible to do, right? So it's depending on owning of the coins. So this makes almost impossible. 51% attacks are almost impossible on proof of stake chains. So that means Ethereum's currency is not only more stable, but it's also the Ethereum network is also quite stable in terms of security, in theory at least, right? All right. So by the way, just wanted to let you know that even with proof of stake chains, it says that 51% attacks are impossible. They're not really impossible. Now there are botnets which also use blockchain. They're all decentralized blockchain botnets that start taking over the network of the blockchain, and then they slowly take over 51% of the network. So just want to let you know that there's no impossibility anywhere. I mean, it's just this photo that I found, this image that I found on the internet, it's obviously outdated because they probably don't know the latest updates in the in the technology world. This diagram obviously was created by me, and these points were written by me. this image I found somewhere on the internet just to show you the difference. It's a very common image that people use to show the difference between POW and POS. Okay, so I can link a lot of articles in the description. In case you want to read those articles, let me know in the comments. But otherwise, what I'm doing here essentially is reading those articles. Like, I've read those articles already, and I'm just breaking them down for you so that you don't have to spend time to read those articles. But in case you want to look at the source, let me know. I'll put the links in the description. All right, so this was proof of stake. In the next video, we'll learn about the delegated proof of stake. Thanks a lot for watching. I hope you've subscribed because you're getting awesome value here, all for free. So do subscribe to this channel. Thanks a lot for watching. See you in the next video.